Okay, so here we're going to take a look at the case where we have repeated factors, right? So when I say repeated factor, repeated linear factors, I should put that, repeated factors here, linear. Okay, so then this looks something like this, right? Our standard linear factor is ax plus b to some n power. So the way we're going to do the partial fraction decomposition for this is we're just going to start increasing the powers of this linear factor until we have to whatever nth power we have, right? So still the constant remains the same in the numerator. It's always, and these are different constants, right, that we will solve for. A1, A2, A3, etc. And then each denominator gets increased by 1 power. Starts off to the power 1. Right, then it goes to 2, 3, etc. until we get to the nth power. Now we're able to combine case 1 and case 2. So if we're factoring out a polynomial and I get a linear factor that has that is repeated twice, and then a linear factor that is not repeated, then I will use the strategy for having non or unique linear factors for that part of the polynomial. Okay, so here let's take a look here at the example here. So you have ax to the 4th minus 2x squared plus 4x plus 1 all over x cubed minus x squared minus x plus 1. Okay. All right, now I'm going to pause here because here we notice that I can't start doing the partial fraction decomposition yet because of the type of polynomial here. All right, we have the degree is larger in the numerator, so I have to do a little long division. So we'll do that. We'll get x cubed minus x squared plus x plus 1. And then we divide here x to the 4th minus 2x squared plus 4x plus 1. All right, and again, just try to match things up here. We get x to get to the 4th, we need a factor of x, so we get x to the 4th minus x cubed plus x squared plus x. All right, and then subtracting here, we get this first one goes to 0, then we get plus x cubed. There's no x cubed there, so we get x cubed, and then minus x squared, and there's a 2 here. So minus x squared. Okay, and then a minus 2x squared, we get minus, hold on, I miswrote this here, so that's minus. Okay, so here, now I got it right. Okay, so that becomes plus x squared and a minus 2x squared, we get minus x squared, and then minus x plus 4x, we get plus 3x, and then we just bring down the 1. And I can do this one more time, right? I can match up the x cubed by just multiplying by 1. So we get x cubed minus x squared minus x plus 1. And then when I subtract here, right, we get the x cubed goes away, the x squared goes away, and we get 4x, and then the 1 goes away. So I get a remainder of 4x since I can't go any further here. Okay, so now our new integral becomes x plus 1 plus 4x over this whole quantity x cubed minus x squared minus x plus 1 dx. Okay, and now I can work with this one. All right, the x plus 1 straightforward integral. I'm not going to worry about that right now. My next issue here is trying to factor that x cubed minus x squared minus x plus 1. Now right away, just kind of inspection here, especially when it's not a quadratic, we can just try values that you think might work, especially looking at this just by inspection here. I know 1 is going to work, right? If I plug in 1, we get 1, minus 1, 0, and then minus 1 plus 1, 0. So I know 1 is a root. So if I know the root, I know a linear root, I can actually use synthetic division here. Or you can use long division as well. Right? So synthetic division says, all right, let's put all the coefficients, 1, minus 1, minus 1, plus 1. Because I don't need the plus there. All right. And then this will be 1. 1 times 1 is 1. Negative 1 plus 1 is 0. And 0. And then minus 1 here. And then we get 1 times negative 1, negative 1. And then we get 0. So we see there's no remainder. All right. Now the corresponding long division would be x minus 1 times, or divided by, x cubed minus x squared minus x plus 1. And you would come to the same conclusion, right? If you did that, we get x plus 1, the quantity 4x. 1 is a factor, so this will be x minus 1. The synthetic division tells me the remaining polynomial, right? The quotient would be x squared minus 1. Right? It's always reduced by 1 degree. So I start off with a cubic, so this resulting polynomial is a quadratic, right? Where the coefficient of the x squared is 1. There's no linear term x, and then the constant term is minus 1 dx. Okay. All right, and now I can factor this, right? That is a difference of squared, so I'll just bring along the x plus 1, 4x, x minus 1. Difference of squares is x minus 1, x plus 1 dx. And then here, finally, just writing it in its form here, in its fully factored form, we get x minus 1 squared times x plus 1. Okay. All right. It took us a minute, but we are here, right? We're able to have it fully factored, right? And we see that we have a repeating term. We have one non-repeating term, right? The x plus 1, and then one repeating term, that x minus 1. So now, from here, I'm going to go ahead and try to do the partial fraction decomposition here. Okay. All right. So that's what this would look like. So we have 4x, and we have x minus 1 squared, x plus 1. All right. And here, I'll do the non-repeating one, so I can just write that as a over x plus 1. So that takes care of that part. So now for my repeating one, right, I start off with b x minus 1, right, to the first power, and then c x minus 1 squared. All right, but the top terms are always linear, just a, b, c. All right. Okay, and then from here, I go ahead and I solve as I did before, right? I'll start off by first multiplying through by the common denominator, which is x minus 1 squared, x plus 1. All right, so if I multiply through, I'll get 4x on the left side. On the right side, the x plus 1 cancels, so we're just left with a x minus 1 squared. And here we have b x plus 1, x minus 1. All right, and then the last one, we get c x plus 1. All right. And now here again, I'm going to do this by plugging in just values of x. I'll start off by using the roots, right? So let x be 1. All right, so I start off there. So here on the left, we just get 4. And I notice here on the right, in this first term, that makes that 0. The second term, that also is 0, because x minus 1 is a root. And the last one, I get 2, right? 1 plus 1 is 2. So we get 2c equals to 4, or in other words, c is equal to 2. Okay, And now for the next one here, I'll do the other root. X is equal to -1. Okay, so when I do that, notice that the terms with B and C, right, those go to 0, right? -1 here gives this quantity 0. -1 here gives this quantity 0. So on the left, we get -4 when I make x to be -1. And then on the right, we're going to get -1 minus 1 is -2 squared. Well, that's just +4, right? So we get 4a. And we get a to be -1. All right. So that's what I have so far. Now, this only has two roots, this polynomial, right? 1 and -1. So in order to find b, I need to do this a different way. All right, I can't use one of those roots. So here's what we have so far, right? So far we have 4x. I've arrived that a is -1. I don't know what b is. B, we have x plus 1, x minus 1, and then c was 2. All right. So I could take the approach where I distribute everything out and then just kind of gather things and set the terms equal to each other, right? The coefficients. But let's just let x be something else, right? Let x be 0, all right? I can do that, right? I could just say let x be 0. So on the left, I get 0. And then on the right, here, this is 0 minus 1 squared. That's 1, but there's a minus on here, so we get -1. And then here, b, if I plug in 0, we get 1 times -1, so we get minus b. And the last one, 0, so we get plus 2. And then here, solving for b, we get b is equal to 1. All right, so now I can put this all together here. Let me see what I have here. So the integral of x plus 1 and then my partial fraction decomposition was, let's see, a was -1. So it's -1 over x plus 1. B was 1. That's x minus 1. And then C was, where is C there? 2. 2 over x minus 1 squared dx. All right. And now integrating here, we get 1/2 x squared plus x minus the natural log of x plus 1 plus the natural log of x minus 1. Now this last one, not a natural log, right? I actually can't just use the power rule. The power rule there is -2. So I add one that's -1, so -2, 1 over, actually, let me write this like this. X minus 1 to the first power. All right, and again, as always, don't forget the plus c. Okay, so that is how we approach a problem like this where we have a one repeated linear factor. Okay.